Hey guys, my name is Saurabh and today we are going to solve an interesting problem whose name is Mike and task packages. Its code is MIKE2. Difficulty level for this problem is simple and it doesn't require any prerequisite. So let's move to our problem statement. So this is the problem statement for Mike and task packages. Okay. So and task packages are there and there are AI tasks in ith package. Okay, means array will be given where AI index will represent the task present at ith index basically. Okay, they are really interesting and complicated. Okay, but Mike can only solve X task before a contest. Okay, now do you know what Mike makes happy? Write successful packages. And what is write successful packages means? A package of task is successful means all the tasks of a package is successful. So it is basically successful package. So Mike is happy. Now do you know what makes Mike sad? Right, failed packages. So what is failed package? A package of task is failed if Mike solved less than a half of the task in it. So please help Mike to organize his training session. Now Mike wants to minimize the number of failed packages. If there are several ways of doing this, he wants to maximize the number of successful packages. Remember also he can't solve more than X task before the contest. And you can see that n and x, the first line contains two integers n and x. So there is not t means number of test cases. N and x are given only. So n will be the number of packages and an array will be given which will denote the task present in ith package. So n and x will be given n and x. X means he can only solve x problems before a contest. So x problems and n is the number of packages and an array will be given with size n. So at every point a value will be given. So a1, a2, a3 dot an. So Mike wants to minimize unsuccessful packages. So minimize unsuccessful packages. Minimize unsuccessful packages and maximize successful packages. Maximize successful. So unsuccessful means less than half of the problem are solved only. And successful means all the problems are solved. Okay. And there he can only solve X packages means X problem. So the basic approach is that choose the package which have the least task so that we can simply solve that. Okay. So first of all sort this array so that we can access all the elements in the ascending order. So first of all, if this is an array ARR, then first of all sort this array. So ARR of sort. Now we have packages in sorting order. So suppose A2, A3, then A1, then A4, and then dot an. Okay. So this is the situation after sorting. So first of all, at least complete half of the packages so that we can minimize this unsuccessful part. So we have X. So just run a loop so that we can minimize it. So for I in range n. So we are running a loop for this array. So for I in range n, every time we will access a particular element. So element is equal to array of I. So first index element will be A2. So first of all solve at least half of the problem. Okay, means if this is A2 then A2 by 2. So simply take ceil value. So if we have 5 tasks then we will simply solve 3 tasks. Okay, so we can simply take element is equal to array of I and then divide by 2 and then take ceil value. Okay, means at least we have to solve these number of elements so to avoid that unsuccessful submission. So if we solve these amounts of question, then our x will be x minus that element. So first of all check if ELE is less than equal to our x. Okay, so if this is less than equal to our x, then simply minimize our x is equal to x minus element, means we solved half of these packages, and just update this array. So array of I is equal to array of I minus x, sorry, minus el. Okay, minus el, and let's take unsuccessful. So unsuccessful is equal to n in the starting, and successful is equal to 0 in the starting. So simply decrement this unsuccessful. So us is equal to us minus 1. Okay, and at any point of time, if this condition is not right, then simply break the loop. So when this loop will finish, then we will solve all the unsuccessful submissions. Means we can simply avoid all the unsuccessful submissions. Okay. Now we have avoided. Now simply talk about successful. So we have x, updated x. We can see updated x. So just run a loop for I in range n. Okay, and just take if we have x, if array of I is less than or equal to x, then simply solve all the tasks. So array of I equal to array of I minus x, and simply increase our successful summation. So sc plus equal to 1. And in else part, and also decrement this x, because we have solved a RRI problem and we have only x problems to solve. So x is equal to x minus array of I. Now if this is not true, then simply break, and in the last we can simply print our unsuccessful summation, then successful summation. So we are increasing the successful submissions and we are decrementing our unsuccessful submissions. Okay, so we know the logic part. Let's code it. So take two variable as input, n comma x is equal to map of int and then input dot split. Now we have n comma x. Now take arr and just take it in form of list. So list of map and then int comma input dot split. Okay, now we have an array. Just take unsuccessful submissions as n in the starting and successful submissions is equal to 0 in the starting. So first of all, let's run a loop. So for I in range n, and every time we will create an element. So element is equal to array of I divide by 2, then take CL value and just import math. So from math import asterisk. So now we have that element ELE. So we have an element. So if that element is less than or equal to our x, means we can solve half of the problem. So simply solve it. So if we have solved these problems, so array of I will be decrement by that element. Okay, now array of I is equal to array of I minus element unsuccessful submissions will be decremented by 1. Okay, and if this is not the case, then we can simply break our loop. And one more thing is that we will decrease our x. So x is equal to x minus ELE, because we have solved ELE task and we have total x task. Now let's this loop again. So for I in a range n, so if array of I is less than equal to x, means we can solve the remaining problem. So there is no need to decrementing this array of I, because as we all know that if array of I is less than equal to x, means we will simply solve all these problems. Okay, so array of I will be 0, so there is no need to use it, and we will simply increment our successful summation. So ss plus equal to 1. Okay, and just decrement x is equal to x minus array of I, and if this is not the case, then simply break our loop. and in the answer we will simply print our unsuccessful submission, comma, successful submission. Okay, so this is the whole problem, but we have to sort this array in the starting. So just use array dot sort. So this will sort that array. Okay, now let's check 3, 10, then 3, 4, 5. 3, 10, 3, then 4, then 5. Let's run this. The answer should be 0, 2. Okay, answer is 0, 2. Let's submit this code. Okay, great. Our code is successfully submitted. Let's talk about C++ part. So this is our C++ code, same as Python. So n, x and I, failed, success. So this is number of failed packages, and this is number of successful packages. We run a loop for I is equal to 0, I less than n, I plus plus. So we have inputted our array. Now we have sort. Now failed is equal to n in the starting, and we run a loop for I equal to 0 and I less than n, I plus plus. Every time we are checking that this value, if this value is less than equal to x, then we will simply decrement our x. So x is equal to x minus array of I plus 1 divided by 2, and we are updating this array. So array of I is equal to array of I minus this value. Now failed minus means we are decrementing our failed by 1, and we are running our loop again. So for I is equal to 0 and I less than an I plus plus, every time we are checking if the updated array is less than equal to that x. So we can simply decrement our x, and we can increment our success, and in the last we can print our failed and our success. So this is our C++ part. Now let's move to some error code. So this is our first error code, okay, written in C++, n, x, and we have take input as an array. Now we have sort this array, okay. So for I equal to 0, I less than an I plus plus, every time we are calculating that value, if this value is less than or equal to our x, then we are simply decrementing our failed packages, and we are decrementing our x. So x is equal to x minus array of I plus 1 divide by 2, okay, and we also have to decrement our array of I. Now let's check for second error code. So this is the second error code, okay, int main n, x, I is equal to 0, I less than n. So sort, okay, sorting is good. Now sum is equal to 0, means a sum variable is taken with 0. Now I is equal to 0, success is equal to 0, and failed is equal to n. Now while sum plus array of I plus 1 divided by 2 is less than equal to x, okay, means we can run this loop. So we are incrementing our sum variable, and we are decrementing our array of I. Now failed minus and I plus plus. Now this is a loop if sum less than x. So this is the wrong part here. Suppose you have an array like 1, okay, of size 1. So first of all, in this case, successful is equal to 0 and unsuccessful is equal to 1, and in this loop we are decrementing ceiling value. So we will decrement this array, and we will convert this in form of array of 0. So this is array of 0. Now in this second case, okay, in this second case our summation is 1. Now 1 less than 1. If 1 less than 1, so this loop will not run in this case, and if this will not run, then this successful will not increase here. So in this case our answer will be the number of unsuccessful is 0 and the number of successful is 0, but our answer should be 0, 1, because we have to run this loop. So instead of sum less than x, we have to use sum less than or equal to x. So this was our today's video. If you like the video, then kindly like and share as much as you can. And if you have any query in your mind, then kindly post it on our YouTube channel. And the most important thing is that kindly subscribe our YouTube channel, and we will meet in our next video.